All right, here is the last video for the chapter. Chapter 1, Section 7, we're going to talk about inverse functions. Now, on what we're going to do is the inverse functions section, it's going to be one large section, one video, because you really don't need to do the first video because it kind of explains it all. So just to let you know, the homework is, the first homework assignment was page 71 through 12 all, and then the second one is page 70, 13 through 43 all. You will be using the graphing calculator. You cannot do this section without the graphing calculator. So just be aware of that. All right, so let me remind you what inverse functions are. You did learn this in Algebra 2. Inverse functions are, the easiest way to say it is when x and y switches. So we're going to look at these two right here first. Here is the function. Just a function of points, okay? That's all I'm looking at. So I have this function of points, and so when I look at it, I hear here's x, 1, 2, 3, and here's y, or f of x is 4, 5, 6. Well, to find the inverse, I switch them. Here's 1, 4, now here's 4, 1. Here's 2, 5, now here's 5, 2. Here's 3, 6, so here's 6, 3. So all I'm doing is switching x and y. Well, also too, if you notice I'm not putting y here anymore, I'm putting f of x. So the inverse notation is f, and it's like a little -1 of x. So what you're doing is you're switching x and y. So just if I was to graph it, we look at the line, the y equals x line, because if we switch y equals x, it's still going to be y equals x. And if we look at it, here's, right here, this chart table of numbers, here are these 3 points, and here's these 3 points. So if I was to fold along the y equals x line, so if I fold the graph, the inverse and the function graphs would fold right on each other. It's just really kind of neat. So the first thing we're going to do is, can you tell if the inverse of a function is a function? So remember functions, we always did vertical line tests. So like if I was to say, is this graph a function, you would draw vertical lines and it would only cross it once and you would say, yes, it is a function. And same thing here, I would draw vertical lines and you say, yes, that is a function. But if I wanted to find out if the inverse is a function, what is the opposite of vertical lines? Because I'm switching y equals x. Well, that's the horizontal line test. So I draw horizontal lines. So when I draw a horizontal line here, it crosses twice. So the inverse is not a function. Okay? If I draw horizontal lines here, this one, the inverse, is a function. So to find if a equation is a function, you use the vertical line test. To find if the inverse is a function, you do the horizontal line test. Pretty easy. That's all you're doing on the first 12 problems. You graph them in your calculator and you look at the graphs and just all you're saying is yes or no. All right, so now what we're going to do is we are going to actually determine what are the inverse functions. Now, your algebra is going to be really big in this section. So here we go. I'm going to use the function x minus 1 over x minus or plus 2. So this is the function so far. Well, very first thing you need to do is, the directions always says, determine whether f has an inverse function. So that's the first statement. Determine if it is the inverse is a function. So what you're going to do is you're going to graph it in your calculator. So graph it in your calculator and do the horizontal line test. Well, if you were to do that, the graph looks something, I'm going to draw it really bad, but looks like this, okay? And remember, this is increasing or whatever. So the answer is yes. The inverse has a function because of the horizontal line test. So you are going to be using the graphing calculator. I cannot stress that enough. So now what we have to do is actually find the inverse function. So first thing is first. F of x, we're going to go back to algebra 1 and we're going to call it y. So x minus 1, x plus 2. Okay, that's the very first thing we're going to do. Now to find the inverse, remember, all you do is switch x and y. So I'm going to make it x equals y minus 1 over y plus 2. So if you can notice, here's the function. Now I'm trying to find the inverse function. So I'm switching x and y. So now what I do, I solve. That's all I do. So this would be, I'm going to put this over here. I get x, y plus 2 equals y minus 1. I'm going to go ahead and distribute. So I get xy plus 2x equals y minus 1. Now I need to get the y's on the same side. So xy minus y equals negative 2x minus 1. Factor out a y. So I get x minus 1 equals negative 2x minus 1. And then I'm going to divide x minus 1 on both sides. So what I get is y equals negative 2x minus 1 over x minus 1. So now what I've done is I have actually found the inverse function. So I had to denote it. There's the negative 1 is negative 2x minus 1 over x minus 1. The next thing what you have to do is you have to state the restrictions in the domain. So when I'm looking at the restrictions, sorry for that. So now we have to do is state the restrictions in the domain. So what can the denominator not equal? Well, the denominator cannot equal 1. If I wanted to actually write the domain, so here's a review. I would have from negative infinity to 1, union 1 to infinity. So that's the actual domain of the function. But what you're doing, so hopefully I'm going to review all this again, okay? So what you're doing is we are finding the inverse function. So first thing you do, you take the function, put it in the calculator and graph it. Then what you're going to do is the horizontal line test. The horizontal line test will determine if the inverse is a function. If it's not a function, we stop. It's not a function. If it is a function, what we do now is take the f of x and make it y. We switch x and y. We do a lot of algebra. That's algebra. We denote it, and then we figure out what the restrictions are. So remember, denominators cannot equal 0. If it's a radical, you have to make sure it's greater than or equal to 0 or whatever it is underneath. And okay, the next thing what we're going to do is we're going to verify if two functions are inverses. So let me get all this ready. All right, so now what we're going to do is we're going to verify. So to verify if a function and its inverse is really an inverse of each other, what we use is we do f composite of the inverse function of x, and that just equals x, or f inverse composite of function will equal x. ACT likes to do this a lot, and so just kind of bear with me on this one really fast. They'll give you a problem like this, and they won't give you anything else. And so they'll say, well, what's the answer to this composite function here? Well, the answer is 3, because we're just trying to prove it's x. That's just a little shortcut. But anyway, so let's prove one. f of x equals 6 over x minus 4. And the inverse, and they actually say it's g of x in the book because you're trying to prove if it's an inverse. So let's do that. G of x is 6 over x plus 4. So the question is, state whether f of x and g of x are inverses. So instead of working it all, we can go f composite of g of x is f of g of x, which is f of 6 over x plus 4, because I'm plugging it in, it's like the last video. So now I'm going to just plug it in, 6 over x plus 4, and then put the minus 4 in. Alright, so now it's just algebra. This crosses out, so I get 6 over x. And you simplify this, so you remember how it is. 6 over 1 over 6 over x. And so This becomes the numerator, so 6x. This becomes the denominator, 6. And the answer is x. Since I got the answer was x, yes, they are inverses. Pretty simple there. All right, so your homework, the first half is 1.7, page 70, 1 through 12 all, and the second half is page 70, 13 through 43 odd. If you have questions, please ask, but that's it. That's it for chapter 1. I'll start getting chapter 2 stuff ready, and your test, start working on the test. You're going to get a lot of extra days to make up this test and make up the work, but stop getting behind.